Okay, these numbers, 1, -4, and 3, we already know this, we've already seen this, but I want to reinforce it because the terminology is probably not that deeply ingrained at this point. What are these values called? These are called the zeros of f of x, the values of x at which the function is 0. The solutions to the equation f of x equals 0. And those are the points at which the graph of the function goes through the x-axis. Okay? And we already know what to call this value. The value f of 0 is the y-intercept. Okay, now a couple of comments in here, a couple of things we want to observe because these are important. Very important for what is coming soon. Okay? At -4 and at 1, f of x takes value 0, right? Now between x equals -4 and x equals 1, there are no zeros, which means that if f of x is positive anywhere between here and here, then the graph has to stay above the x-axis all the way, because in order to go to the other side of the x-axis, it has to go through the x-axis, and it can't go through the x-axis between here and here because these are the only zeros. Then we also know that the function is positive here, so that means once it goes through here, it's got to stay positive till it gets here. So I summarize that by saying there are no zeros between here and here. The brackets indicate here, the brace indicates here and here. So the function is always positive for all x values from here to here. That's the meaning of this note. Similarly, between 1 and 3, there are no zeros. So if the graph is positive anywhere between 1 and 3, it has to be positive everywhere between 1 and 3, meaning the graph would have to be above the axis. And if it's negative anywhere between 1 and 3, it has to be below the x-axis. So what we do is we just pick a number between 1 and 3, 2 being an obvious one, easy to evaluate. And we evaluate the function for x equals 2. Well, we get 2 minus 1, which is 1. 2 plus 4 is 6. 2 minus 3 is -1, so we have -6. That's negative. Since it's negative here, and it can't go through the axis anywhere between here and here, it has to be negative everywhere between here and here, so the way we drew the graph is perfectly valid. Okay? Those are important things. Now there's a question here that I've already answered. How did I know that -10 would give me a big negative number? Just to review that answer. Well, -10 is on this side of all my zeros, meaning that if I do -10 minus 1, I'm going to get a -10 plus 4, -10 minus 3. They're always going to be negative. The negative is always going to be bigger than the other number, and the other number might well be negative as well. And on the right, as I explained, we get a big positive number if we move a good ways to the right. And I didn't move that far. I only moved to 10 and -10, and I'm already up near 1,000. 50 feet high, 100 feet high, 50, 100 feet low. If I went to 20, I'd be 8 times that far. I'd be hundreds of feet high or hundreds of feet low. So those are the purple notes, and ignore this physics over here. But next thing we want to do is look at what would happen if we had the same function here, but if the x minus 3 was squared. That would change some things. It wouldn't change our zeros, but it would change a lot of other things.